All right, continuing with the study guide. I'm going to try not to make this video quite as long, but who knows? Okay, so after electrostatics, we talked about circuits this semester. So circuits are where we've got a moving flow of electrons, and this is where we talked about things like voltage and current and resistance. And so what we're going to do first is kind of do some comparison between the two types of circuits that we looked at. Okay, so let me refresh us really quick on what those are. Okay, so we talked about series. Series circuit is where you've got, say, we've got a battery, and then we've got our resistors or our bulbs, whatever our components are all in one loop. They're connected in a series. Okay, so everything's together. And then we talked about parallel circuits. Parallel is the type of circuit that has the multiple pathways. Okay, so we've got 3 resistors in each of these just for comparison purposes. So with parallel, each of these is a separate pathway. And that makes these two have differences between them in terms of how we did the calculations and also how they work, like their circuit behavior, I guess. So let's go back and look at this list of items that. So first of all, adding a resistor increases total resistance. Okay, so which one does that go with? That does that go with series or parallel? Remember, with series, as you, I'm just gonna have to go back and forth, I guess. As you add more resistors, the total resistance of the circuit is based on the sum of these. So every time you add another one, you're gonna increase your resistance value. Okay. So increasing total resistance is series. Decreases total resistance. Okay, that's going to be parallel. Remember, with parallel, every time you add another resistor, you're adding another pathway. You're adding a whole nother pathway. We could just keep adding these. And what you're doing is giving the current more pathways to flow through. So you're decreasing its resistance. You're giving it more options. That's like the traffic analogy I said, where if you only have one way you can go home, you might have a lot of resistance. But if you've got more than one way, you've got more than one pathway, then you're decreasing your resistance. Okay. So with series, we're increasing as we add more components. With parallel, we're decreasing. Okay. Adding a resistor increases current. Currents are flow of electrons through our circuit. Remember that, again, with series. Um, so always, whether we've got one type of circuit or another, resistance and current are inverse. So with series, when we add more resistors, we're increasing our resistance, we're decreasing our current. Okay, so that's going to be adding a resistor decreases current. With series, remember the bulbs dimmed when we added more, when we did series circuits. The more components you put in there, the more resistance you get, but the current goes down. Okay. And then parallel, again, same principles, but opposite. Every time I add a pathway, okay, I'm decreasing my resistance, but I'm increasing my current. Each one of these pathways has another current, okay? So every time I add a new one, I'm going to increase my current, okay? Let's see, if one bulb burns out, the circuit turns off. That's going to be for series since they're all connected in one line. If one bulb burns out or gets unscrewed or goes bad, everything goes out. That's one of the pain things about series. Whereas with parallel, they've got multiple pathways, so they can just go a different way, and the rest of the circuit will stay on. If you add a bulb, the others stay the same brightness. Again, parallel, because every time you add a bulb, you're really just adding another pathway. Like you're not impacting the other pathways. So the other bulbs can stay the same brightness. Whereas with series, if you add a bulb, okay, the others are going to get dimmer because you're increasing your resistance and decreasing your current. Okay. Remember here, we're going to say resistance increases and current decreases. So there's less current for those other bulbs to get, so they're going to get dimmer. Okay. Current is the same throughout the circuit. That one is series. So that's the one where we were able to have current be the same value throughout the whole circuit. And then current varies by each pathway. That's parallel. Okay. So just a quick review through of series and parallel like concepts. Okay. And then some quick math. So this just goes back to the main equations we used for circuits. This first one, we've got a 120 volt source, produces 20 amps of current. What's the resistance value? So for this one, we use what we called Ohm's law. Voltage equals current times resistance. Okay. And this was a law we used throughout both of our series and parallel math. Get my calculator out. Okay. This camera angle is strange. Hang on a second. Okay, that's better. All right, so Ohm's law, voltage equals current times resistance. Whenever you see a question where you've got voltage and you've got current and you've got resistance and you're solving for one of those, you could use Ohm's law. Okay, so in the case of this problem, 120 volts is our voltage. 20 amps is our current. Current is amps. Remember, I used CIA, current, symbol is I, units are amps. And then we don't know resistance. We're solving for resistance. So we want to solve this problem. We're going to divide both sides by 20. Okay, and I can do that in my head, but I'm just going to show y'all. So that gives me 6 ohms of resistance. Remember, ohms are that little horseshoe looking thingy. Okay. All right, and then here's another one. A bulb has a 9 volt source and 5 amps of current. How much power is used? Okay, power equals current times voltage. That was another, we didn't use that one as much as Ohm's law. That's another equation. So we're asking for power. We're just going to multiply 0.5 amps by 9 volts. So current times voltage. And that gives me 4.5, and that is in watts. Power is in watts. So probably good to refresh on the units here, because there were a bunch of weird units in that unit. All right, and then last one is the cost of power. So this is how much it costs to use power. This is one we don't have an equation on the equation sheet. We're just multiplying a bunch of stuff together, okay? So we've got a refrigerator. It runs for 3 hours a day, 1.2 kilowatts. That's the power rating. We want to know how much it will cost to run for 30 days, and our power company cost is 11 cents. So we're going to multiply our hours per day times our number of days, because that's what we want. That's the time period we want to calculate this for, times the power rating, times the cost from the power company. So that's giving us hours, days, Okay, so that's going to give me a total number of hours, okay, over those 30 days. Then this is kilowatts. This is how many kilowatts this is using. And then this is my cost. So, and this is a kilowatts per hour, okay? Should have had an hour there. So what I'm going to end up with is my cost for these kilowatts over the time period. So I'm going to do 3 times 30 times 1.2 times 0.11. And this one, again, it's not on your equation sheet, but it's just like literally multiplying a bunch of stuff together. So it cost me $11.88 to run my refrigerator. 3 hours a day for 30 days at that rating and that cost. All right, so that was a quick review over circuits.